Good evening, ladies and gentlemen. Thank you for giving me screen. I will today talk about hydrogen production and as in general, mostly on my publication published in International Journal of Hydrogen Energy, made by Professor Rafa and Nujat from Malaysia and Australia, Sydney University. But hydrogen is very important element that is becoming more and more interesting as perfect energy carrier and in competing to storage method, which are usually are developed. The interest is more, especially in case where conventional fuels like oil and gas and carbon are depleted, and they are seeking another renewable method. And that trouble is how to store. The storage is now by thinking usually by hydrates like ammonia or sodium hydrates. However, ammonia is easier, and this ammonia is context with one of cells, which is microbial electrolysis cell. From fossil we have two generation possibilities of hydrogen: renewable sources and traditional sources. The hydrogen production for first fuels is by hydrocarbon reforming and hydrocarbon pyrolysis, both in high temperature due to steam, part reforming, autothermal reforming, and this is the traditional using from coal, oil, and gas, mostly from gas, natural gas. In case of renewable sources, we have two sources coming from biomass and water, and from water and mixed. And also some renewable sources, some alternative sources are plastic waste and waste tire waste, which can be also source of hydrogen, but are, let's say, organic waste for fossil fuels. Therefore, we can make by biomass processing, from biomass processing in thermochemical, similarly water splitting and ammonia splitting, some compound, and biological. Thermochemical are gasification, combustion, pyrolysis, and liquefaction, while biological are dark fermentation, photofermentation, biophotolysis, which is special case of water splitting, and microbial electrolysis cell. And what the differences is. In case of water splitting, we have three methods. We have electrolysis, thermolysis, photolysis, and mechanocatalytical splitting. And mechanocatalytical and photocatalytical splitting are mostly similar because mechanocatalysts are already usually photocatalysts, but mechanocatalysts are acquiring only by friction. So friction of these elements and water, for example, is making the little splitting not very high, but up to 5%, And these mechanocatalysts are not applied nowadays in for water because there are several articles from up to 2005, but very small. And photocatalytic is small because it allows to produce hydrogen even from waste, meaning that under the influence of light, this catalyst was when touching the water can split the water bonds producing hydrogen and ammonia also, and some organic compounds from waste also can be as phantom, for example, agent. And water splitting also method is electrolysis and thermolysis, which thermolysis is by heat, so generates much heat, and electrolysis by uh, a source of current. The current can be here, it's it's renewable, it comes from renewable source, so the source, sun or will from wind or solar, and this is case where it's renewable because current is from renewable place, and electrolysis can water split by also some molecules of organic compounds containing like butyric acid, methane, and special case is water splitting by microbial electrolysis. So by some pseudomonas bacteria, which during uh, during digestion of some food for some waste, they generate some voltage. This voltage is enough to split some compounds like ammonia. Therefore, it is considered as is enough so high to store and splitting. So if we produce some hydrogen extra from biological methods, it can be easily transformed by Haber process to ammonia and then stored as ammonia, and then, if on suitable case, split it into hydrogen again by this microbial electrolysis cell. Therefore, but this splitting, water splitting by microbial electrolysis cell is producing 0.4 volts, which is enough to splitting water only ammonia, some molecules, but only ammonia and similar like that. In case of water splitting, we need some extra charging because water needs potential of volts of 1.2 volts to be split. Therefore, mm, ammonia is better because it doesn't require extra energy to perform splitting. Biological other methods are biophotolysis, which it's special because other biological methods of, of organic waste decomposition into hydrogen are only for the organs of bacteria cells. In the case of biophotolysis, of course, we have cyanobacteria, which are quite dangerous because cyanobacteria are not very funny and can make, if too much case, make anoxic state in ocean and water. So we need to sometimes be aware. And but there are also some algae which are very big plants. So it can be used then for production hydrogen in some part, but it requires much wire because it produces in enough hydrogen enough in only in case of several special light conditions. So this generates some trouble. But this algae can be then a source of pharmaceuticals, lipids, and proteins special, and rest can be suitable material for dark fermentation, for the fermentation of a biological composition, like or for methane. But photofermentation is a case when we have bacteria. which can produce for acetic acid, butyric for organic acids, also from sugar, but for organic acid mostly. The splitting into hydrogen. The photofermentation, rhodobacters, are thought to be the very old first bacteria because in our initial times of air, there wasn't be much oxygen, and it's now thought and it's considered that first bacteria were photofermentation and producing hydrogen to compounds, and then were outnumbered by oxygenic bacteria because and there's some are still, but in very specific conditions because they require light and similar to biophotolysis have similar problems, but they can reduce much more waste than algae. In case of dark fermentation, is anaerobic digestion plants, which produce hydrogen from organic waste, especially for carbohydrates, also for fats, but also most efficiently from sugars. And this lower, if not modified, and enzymes which are difficult to obtain, which generate some trouble. The hydrogen production by dark fermentation, which is four-step process, requires still unknown stabilization very much and some limits because hydrogen production by bacteria by dark fermentation is limited by Taylor rule, which sounds that we cannot produce from sour by using pyruvic pathway. So the sugar comes transferred during digestion by bacteria to pyruvic acid and then converts to organic acid like butyric, acetic, and propionic acid. This generates maximal increase of acetic acid, 4 molecules of hydrogen and 1 molecule of glucose. But this shows that from sugar, in this case, we have maximal 33%. And the disadvantage news is indeed that more suitable due to Gibbs energy are butyric acid, which is much lower efficiency than acetic. There are some cases of or adding of special treatment of bacteria which blocks methanogenesis and so preventive of hydrogen production that promotes slightly to acetic, but still is not very high production. There are some other pathway using modified bacteria and modified enzyme that can directly for cellulose and omitting this pyruvic acid, but are still not very well repeatable experiments, but enough to be helpful for another processes like methane or some little hydrogen requiring to upgrading the methane production. This is the applicability of nowadays because dark fermentation allows to utilize much organic waste with different waste, not so big difference like in other compounds. The pyrolysis and gasification from biomass or plastic, it is method which can produce for organic waste besides hydrogen also some alkanes and aromatic compounds in the tar form because after the thermic combustion, because pyrolysis is the splitting of organic compounds under influence of heat only, while gasification also adding some air or oxygen, some gas, which generates some troubles because gasification produces much oxides which are dangerous to people, and therefore it requires much more safety rules than pyrolysis. This is much big the disadvantage of gasification over pyrolysis. Pyrolysis is method of hydrogen very efficient because much 100 more hydrogen per 1 kilogram of biomass can be produced by pyrolysis than biological method and much faster. So which if we want much waste in very fast, pyrolysis is better, but requires much heat. And this, the amount of heat are by someone say some researchers say that are too high to make production of hydrogen production by pyrolysis enough profitable. But most are supporting, and because it allows to produce beside hydrogen other components which are useful for as kerosene, other compounds useful as biofuels. The storage is how in the hydrants, and also are some compressing methods, but still are much more expensive than or cryogenic and requires much better and much expensive storage tank and difficulties to the transportations. The hydrogen fuel is better than others that produce only water and not other compound, not other waste, which is advantage. And this is all for today. Thank you very much for my listening me. Thank you.